Bismillahirrahmanirrahim. Dear students of class first year, here we have exercise 1.2, question number 10. Separate into real and imaginary parts for the following complex numbers. Here we have total number of parts 8. Part 1. We have to separate its real and imaginary parts. So let us suppose that the given complex number is equal to x plus iota y. That is, let x plus iota y is equals to 2 plus 3 iota. By comparing, real part is equals to real, we have x equals to 2, and imaginary part is equals to imaginary part, that is y is equals to 3. Thus, real part is 2 and imaginary part is 3. Now part second is 3 minus 2 iota whole square. Now students, you can do this part very easily. You have to solve 3 minus 2 iota whole square by using formula a minus b whole square. Then after solving, you will get one real part that will be equals to x, and one imaginary part with the iota term that will be equals to y. So you can separate real and imaginary parts by showing x and y. Part third. 3 minus 4 iota whole raised to power minus 1. Let x plus iota y is equal to 3 minus 4 iota whole raised to power minus 1. First, we can write it as 1 divided by 3 minus 4 iota. Why? Because when we will take minus 1 power with denominator, it will become plus 1. Now solving it by using multiplying and dividing conjugate of 3 minus 4 iota, that is 3 plus 4 iota. So we have 3 plus 4 iota divided by 3 square minus 4 iota square, which is equals to 3 plus 4 iota divided by 3 3s are 9 minus 16 iota square, that is iota square minus 1, minus minus plus 16 plus 9 25. So writing separately with 3 by 25, then 4 iota by 25. Now comparing real part with real and imaginary with imaginary, we have x is equals to 3 by 25 and y is equals to 4 by 25. Thus our real part is 3 by 25 and imaginary part is 4 by 25. Now part fourth. 2a minus b iota whole raised to power minus 2. Let x plus iota y is equal to 2a minus b iota whole raised to power minus 2, which can be written as 1 divided by 2a minus b iota whole square. Solve it by using a minus b whole square. We have a square plus b square minus 2ab. So here 4a square minus b square, because iota square minus 1, minus 4ab iota. Here we have 4a square minus b square real and minus 4ab iota imaginary. Now multiplying and dividing by the conjugate of this complex number, whose conjugate is 4a square minus b square plus 4ab iota. Here we have 4 in numerator 4a square minus b square plus 4ab iota, and for denominator we will use formula a minus b, a plus b, which is equals to a square minus b square. So it will becomes, now here using formula a minus b whole square, we have 16a4 plus b4 minus 8a square b square minus 16a square b square iota square. Iota square minus 1. So it will becomes plus 16a square b square, 16a square b square minus 8a square b square becomes 8a square b square. So now we have finally 16a4 plus b4 plus 8a square b square is the formula of 4a square plus b square whole square. So we will write in the form of 4a square plus b square whole square. Dividing separately, we have 4a square minus b square divided by 4a square plus b square whole square. It will be real part x, and when we will divide with the 4ab iota, its imaginary part will be y is 4ab divided by 4a square plus b square whole square. Now students, for next part 5, 6, 7 and 8th of question number 10, I will give you hints. and I will explain it for you, then you have to solve it, these questions. Part 5 is 3 minus 2 iota divided by minus 1 plus iota. Now to find its real and imaginary part, we will solve it by using a method for two complex numbers. When we have in division form, we multiply and divide by the conjugate of denominator complex number. Here we will multiply and divide it by minus 1 minus iota. We will multiplying and dividing by minus 1 minus iota. Then after solving, we will get one real part and one imaginary. Real part will be shown by x and imaginary by y. Part 6. 5 minus 2 iota divided by 2 plus 3 iota whole raised to power minus 1. Now we can write it as 2 plus 3 iota divided by 5 minus 2 iota whole raised to power 1. That is, no need to write whole raised to power 1. Means when we will take its reciprocal, the power of the sign of power will becomes plus 1. So then after it, we will solve it by using the same method as for part 5, that is multiplying and dividing by the conjugate of 5 minus 2 iota, that is 5 plus 2 iota. Number 7th. Square root 3 minus iota divided by square root 3 plus iota whole raised to power 2. Now let x plus iota y is equals to under root 3 minus iota divided by under root 3 plus iota whole raised to power 2. First we will take their separate squares, then using formula a minus b whole square for numerator and a plus b whole square for denominator. Then when we will solve it, we will get taking 2 minus 2 square root 3 iota divided by 2 plus 2 square root 3 iota. Taking 2 common from numerator and denominator, finally we will get 1 minus square root 3 iota divided by 1 plus square root 3 iota. Now we will multiplying and dividing by the conjugate of this denominator complex number, that is 1 plus 3 iota square root 3 iota, whose conjugate is 1 minus square root 3 iota. And this is continued, you can see, and when we will solve it, finally we will get a real part, and we will show real part by x, and one imaginary part we will show imaginary part by y. You have to solve it further. Now the last part, part number 8th, which is equals to 1 plus square root 3 iota divided by 1 minus square root 3 iota whole raised to power minus 2. Now when we will take its reciprocal, or when we will change, it will becomes 1 minus square root 3 iota divided by 1 plus square root 3 iota whole raised to power plus 2. And then we will solve it by using the same method, that is first taking their separate squares and solve it, finally multiplying and dividing by the conjugate of denominator complex number, and then finally getting value of real part, which will be shown by x, and imaginary part by y. Thank you, students.